Welcome to the third part of VCAA Mathematics 2020 exam paper series. In this video, we will present exam paper 1, questions 7 to 8. For question 7, part A, some students simply stated f of 1 equals 9 without explaining the relevance of the question. Some even found the discriminant of the quadratic was negative that was not related to the question. In question 7 part B, many students wrote down an expression for gradient but went no further in part B sub part 1. In addition, some students made algebra error in dealing with negative coefficients. As for part B sub part 2, though most students recognized that an evaluation of the derivative was required, some incorrectly assumed the question required the equation of tangent at point A. In part B sub part 3, many students who used the equation of the tangent method could not form the correct quadratic equation. The most common error was students assuming that their value of A was the gradient of the line instead of substituting into f prime of A. In question 7 part C, many students used distance formula and then attempt to differentiate and equate to 0, often with limited success due to error in differentiation or algebra. However, students who used a geometric approach tended to score higher. For question 8, part A, the most common errors were incorrect differentiation or incorrect evaluation. In part B, many students made up their working as the answer was given, rather than clearly demonstrating progression to the answer.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Mathematics 2020 exam paper series. In this video, we will present you questions 7 and 8 of exam 1. Now, let's explain question 7. It is a long short answer question and it starts with a given function f of x which equals x squared plus 3x plus 5. Apart from the rule of f of x, there is also a given point P which has the coordinates 1, 0. Part of the graph of the function y equals f of x is shown on the screen. There are 3 parts in question 7. Part A is to show that point P is not on the graph of y equals f of x. In part B, we consider point Q with the coordinates a, f of a to be a point on the graph of f of x. There are 4 subparts in part B, and subpart 1 is to find the slope of the line connecting points P and Q in terms of A. Subpart 2 is to find the slope of the tangent to the graph of f of x at the point Q in terms of A. Here we continue to explain question 7 of VCAA Mathematics Exam 1 2020 paper. In subpart 3 of part B, we let the tangent to the graph of f of x at x equals a, passing through point P, then find the values of a. Subpart 4 is to find the equation of one of the lines passing through point P, that is tangent to the graph of f of x. Part C of question 7 is to find the value k, which gives the shortest possible distance between the graph of the function y equals f of x minus k and point P. Now, let's solve part A of this question. Since part A is to show that P is not on the graph, what we need to do is to show that the coordinates of P do not satisfy the equation y equals f of x. Since f of 1 equals 1 plus 3 plus 5, which equals 9, obviously the point 1, 0 is not on y equals f of x. As for part B, The subpart 1 is to find the slope of the line connecting points P and Q. Hence, the slope equals rise over run, which gives that m equals f of a minus 0, or over the result of a minus 1. Since f of a equals a squared plus 3a plus 5, which gives m equals a squared plus 3a plus 5, or over the result of a minus 1. Since the part 2 is to find the slope of the tangent to the graph of f of x at the point Q, we may work out the differentiation of f of x. So f prime of x equals 2x plus 3, which gives f prime of a equals 2a plus 3. As for subpart 3, since the tangent to the graph at x equals a passing through point P, we have the equation a squared plus 3a plus 5, or over the result of a minus 1 equals 2a plus 3. Solving this equation, we obtain a equals negative 2 or 4. Here we continue to answer part B of question 7. Since subpart 4 is to find the equation of one of the lines passing through point P that is tangent to the graph of f of x, we need to use the values obtained in subpart 3. When a equals negative 2, the gradient is 2 times negative 2 plus 3, which equals negative 1. Accordingly, the line equation is y minus 0 equals negative 1 times x minus 1, or in parentheses, as it can be seen, which becomes y equals negative x plus 1 after being simplified. When a equals 4, the gradient is 2 times 4 plus 3, which equals 11. So the line equation becomes y minus 0 equals 11 times x minus 1, or in parentheses, which is written to y equals 11x minus 11 after being rearranged. As for part C of question 7, it is to find the value k, which gives the shortest possible distance between the graph of the function y equals f of x minus k and point P. Since the coordinate point P is 1, 0, if the minimum point of f of x minus k is at x equals 1, the shortest distance between P and the function y equals f of x minus k is actually the minimum value of f of x minus k. Since f of x minus k can be written to x minus k, or in parentheses squared, plus 3 times x minus k, or in parentheses plus 5, which can be written to x minus k plus 3 over 2, or in parentheses squared, plus 11 over 4. So when negative k plus 3 over 2 equals negative 1, which gives k equals 5 over 2, the shortest distance between P and the function y equals f of x minus 5 over 2, which equals 11 over 4. In question 8, part of the graph of y equals f of x is shown, where the rule of the function is x logarithm base e of x, and the domain of the function x is greater than 0. As shown in the diagram, the graph of f of x has a minimum at point Q, and its coordinate is a f of a. There are 4 parts in question 8. Part A is to find the coordinates of point Q. Based on the differentiation of x squared logarithm base e of x with respect to x equals 2x logarithm base e of x plus x. Part B is to show that x logarithm base e of x has an antiderivative x squared logarithm base e of x over 2 minus x squared over 4. Part C is to find the area of the region bounded by f of x, the line x equals a, and the horizontal axis over the closed interval from a to b, where b is the x-intercept of f of x. In part D, that the function g of x equals f of x plus k, where the domain of g of x is greater than a, and here k is a real number. Part D has two subparts, and subpart 1 is to find the value of k for which y equals 2x is a tangent to the graph of g of x. Here we continue to explain on part D of question 8. Subpart 2 of part D is to find all values of k for which the graph of g of x and its inverse function do not intersect. Now let's answer this question by starting with part A, which requires finding the coordinates of point Q. Since f of x equals x logarithm base e of x, its derivative f prime of x equals logarithm base e of x plus 1. We set f prime of x equals 0, which gives x equals 1 over e. Hence, f1 over e equals logarithm base e of 1 over e all over e, which equals negative 1 over e. So the coordinates of point Q is 1 over e, negative 1 over e. In part B, since the differentiation of x squared logarithm base e of x with respect to x equals 2x logarithm base e of x plus x, the integral of the differentiation of x squared logarithm base e of x with respect to x dx equals the integral of 2x logarithm base e of x with respect to x plus the integral of x with respect to x, 2 times the integral of x logarithm base e of x with respect to x equals x squared logarithm base e of x minus the integral of x with respect to x. Hence, the integral of x logarithm base e of x with respect to x equals x squared logarithm base e of x all over 2 minus x squared over 4. To answer part C, we need to calculate values of both a and b first. Now we recall part C of this question, which is to find the area of the region bounded by f of x, the line x equals a, and the horizontal axis over the closed interval from a to b. Since f of x equals x logarithm base e of x, and according to part A equals 1 over e, and b equals 1. So the bounded area, as shown in the diagram, can be written to negative integral from b to a of f of x with respect to x, which equals negative integral from 1 over e to 1 of x logarithm base e of x with respect to x, which equals x squared logarithm base e of x all over 2 minus x squared over 4, all valued from 1 to 1 over e, which equals e squared minus 3 all over 4e squared after being simplified. In part D, function g of x equals f of x plus k, where the domain of g of x is greater than a and k is a real number. Subpart 1 is to find the value of k for which y equals 2x is a tangent to the graph of g of x. So, g prime of x equals f prime of x equals logarithm base e of x plus 1 equals 2, which gives x equals e. Since g of x equals f of x plus k, which equals 2x, hence k equals 2x minus x logarithm base e of x. Given that x equals e, k equals e, subpart 2 is to find all values of k for which the graphs of g of x and its inverse function do not intersect. As we know, if the function y equals g of x is above the line y equals x, and the derivative of g of x, g prime of x, is greater than 1, g of x won't intersect with its inverse function. Hence, we have two simultaneous inequalities to satisfy. They are x logarithm base e of x plus k is greater than x, and logarithm base e of x plus 1 is greater than 1. Solving both inequalities, we obtain k is greater than x times 1 minus logarithm base e of x, or in parentheses, and x is greater than 1. Therefore, k is greater than 1 times 1 minus logarithm base e of 1, or in parentheses, which equals 1. So our conclusion is that k greater than 1, when k is greater than 1, g of x does not intersect with its inverse function.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.